Right, this is the class layout. I'm trying to edit from the previous schedule from last year. I did some in this morning. You can see that second line, the Zoom link address. So we will use this same address for whole semester. So I will distribute this Excel file to everybody after class. And Korean students already get this one through the Kakao connection. So please join the Kakao to you, all of your international students. Okay, and then I will show you after this Excel file schedule. Then I will start a few slides of the overview of ocean engineering, and then continue to on Thursday, right. And then goes on to this schedule like this until end of March, and then we start regular classes because you may get some ideas, right? So starting from coastal process, the topic, the chapter, you will have a lecture 20 minutes. Say Mr. Gu, Hee-jung Gu will start up the lecturing, and then discussion will be led by Jang Go this way. So we have 8 students. I don't know whether who is missing. The Julfika Nasir is missing today, so we may change after, say, next week something, the schedule. But anyway, this is the format I'm trying to cover and repeating in this way. And there will be a project proposal. So there will be 3 presentation of term project. Okay. So project proposal presentation and midterm exam is only one exam, written exam, and midterm project presentation, and then final presentation. There is a 3 part of term project. And sometimes I will invite other professors for special lecture for special topics. And then there will be 3 homework. Right, that's the way we are trying to do the class. Okay. Question to schedule? No question. All right, then I may go
What's
on.
the difference between lecturer and discussion leader? I mean,
right, lecture. I have an old material of lectures, PPT. So I will give you a portion of PPT you can cover for the lecture.
I see.
But discussion will be any topic. But usually I hope you can lead the discussion around the lecture material. But it is not limited to. So my experience from previous year saying that every discussion leader find out topic from his idea or from his survey, I don't know. So he usually provides several, 1 or 2, 3 questions to student, and then start to discussion. You may get idea from the previous years because there are videos and also materials of discussion session.
Okay, thank you.
Okay. All right. Somebody send the chatting material. No. Any other question? Okay, then I can continue on to another material. Right? So we already covered this one. Right? Right. Okay. Ocean engineering. Right, this one. I guess this one is also already tips through the email to you last night. Right, this is the introduction to ocean engineering. Overview of ocean engineering. Right. So this is the book again. The left-hand side, this is the book I'm trying to cover, but not all of them, only a portion of them, the book. Right. This is a chapter names of ocean engineering. So I'm trying to cover the first chapter today. Small, but on Thursday I will finish up this slide set. And then chapter 2 is about environment, and 3 is offshore structure. And we jump to, say, chapter 6 of floating and submerged body dynamics, underwater systems, underwater acoustics, and instrumentation for ocean applications. The chapter 8 is important for Navy, but also many submarines, also the fishes underwater. You know that, you may not know that the underwater inside the ocean, among the water, if you divide into the telecommunication is not working. Only sound is working. We cannot use a microphone, smartphone. Microwave or electromagnetic wave is not working inside the water. That's why the sound and acoustics is important. So that is the only way we can communicate, we can survey, we can watch the enemy. So that is the problem inside. Oh, that is the reason why the submarine is important, because the detection of enemy submarine is not easy because of the problem of acoustics. So we will see more on this chapter. But anyway, this is the specialty, right, in ocean engineering. One of the specialty, right? So ocean is unexplored, right? There are many places you can explore in ocean, especially the seabed. There was no such a good technology to explore or utilize the ocean and seabed. That's why we have more frontier there. And surface-wise, Earth's surface, 70% is ocean. And water-wise, is almost of the water is in ocean. And then unexplored portion of ocean is 95%. And the diving, water diving or scuba diving, the recreational diving depth is about 30 meters. You trying to have skin scuba diving is a kind of recreation. We usually limited by this depth, and technical dive is limited by 50 meters. So for the Korean student, there was a two big disaster inside Korea. One is Seoul-ho. Seoul-ho is a passenger carrier. More than 300 people died because of the capsize the ship, passenger ship, the young high school student. And you may not remember that the water depth there, that was around 40 meter, 40. So it is about between recreational dive limit depths and also technical dive limit. That's why there was a problem to rescue operation of scuba divers there at the time. Right. And saturation dive is a special kind of device using some high compressed air, and so that there's the way. Right. And average depth is average depth of the ocean around the world is 4 kilometers. Right. And then deepest place is about 11 kilometers. I can't remember. So the international student, you fly from your country, say Sweden or France or Vietnam. Do you know how was the aviation height from the Earth of big plane,
I think it's
airplane?
about around 10 kilometers, 11 kilometers above
Say
sea
again?
level.
How
I
many?
think it's about 10, 11 kilometers above sea level.
Right. You know well. Right. About a big airplane fly long distance, say from Europe or United States to Korea. The height is around 10 kilometers average at the steady flight stage.
Yes.
So you may see that deepest trench is about 11 kilometers depth. Right? So about same distance. Right? Okay, next slide. Facts. Once again, similar things again. World trade volume or weight, you can say. World trade is carried by ocean-going ships. Right. In Korea, because we have no landside connection to China because of the North Korea, almost 99%. Remaining 1% is air traffic, but this percentage is coming from weight rather than price. Because the 1% of flight cargo is very expensive. So if we count through the price, then it can be higher. But anyway, weight-wise, so heavy material is using ships through the ocean surface. Most of them. And all water, among them 2% is frozen in North and South Peak. And there are inland lakes, channels, that is very small, 0.02. And life on Earth, 80%. Protein, right? Fish production, very important. And also cheap, not expensive. So we can get a good quality of protein coming from ocean. Volcanic activity also 90%. And oil, 1/3 of the world oil is coming from ocean now. But the percentage will be growing in the future because oil in the land is empty nowadays because we already use many of them. So the oil reservoir in land side is already becoming empty. Right? But ocean reservoir is still remaining, but problem is it is deep inside the water depths, so that the cost of production is high. Also, it takes more challenge in terms of technology and also safety and so. But anyway, in the future, because oil in the land side is going down, right? That's why you need to learn this one. This one is very interesting picture. I'll show you from the YouTube. That I hope it's working. Okay, okay. This is United States, Florida, Gulf of Mexico, going down to South Africa, South Africa. The Middle East, Saudi Arabia, India, Bangladesh, Indonesia, China. It comes to the Korea and Japan. You can see the current of global size current. So we stop the video, turn back to PPT, PowerPoint. Any question until now? No. What time is now? Okay, only. Right, question?
Did it just show the currents that are linked together around the world? I was not entirely sure about what the video showed. Like all the currents around the world are linked. Is that what it showed?
What is your question again?
The video, was it showing like the wave patterns around the whole world, or ship trading? I mean, ship waves or something.
Oh, that is a ocean current.
Ocean current.
Ocean current. Well, ocean current, there are so different types of ocean current, but this one shows global scale, biggest current scale. Global scale means, say, the size of current is something like more than 100 kilometers or 1,000 kilometers, right? Because comparing to the size of the nation, so it's a global scale current, we say. Because of the rotation of the Earth, and also wind and also working force coming from moon and sun, there is a global scale current. But it is important, you see, and the direction of the current gives you, say, for this picture, upper picture, there is a, you see the current coming from Philippines, and then Taiwan and Japan, right? And so direction of current is coming in this way, in this around the whole year, the same direction, and gives you warm water coming from the south equator warm area to the Japan and Korea, and then together with special kind of fishes. And another important issue we can learn from this current global scale current, that in say 3,000 years ago or 2,000 years ago, the transportation of human was no engine at the time, only wind and current, and the ship is built in wood, no steel, so that people at that age, say 2,000 years ago, they transport from, say, Philippines, Taiwan, China, South China, and then arrive at Japan and south part of Korea. So that history is moving in this way, based on this global scale current. So temperature changes, and also the fishy kind of movement, and also similarly the human movement in old ways. In nowadays, we do not depend on that current for the human, because we use engine, airplane. So, but and say 2,000 years ago, the history we can learn from that current global scale current directions and speed, right?
And has the pattern of current, has it changed over the years due to human activities?
Right, but this global scale current is almost similar, typical shape and speed and also pattern, right? That's why we are learning. And this one is, the video is made by NASA, and they, I don't know exactly, but I understand that they capture many photos and then processing them and then connect the photos into a video. So you can get more idea from that website. All right, one more slide, then we can finish. Right? So, ocean engineering, the definition. So this is an engineering principle to ocean, right? Main ocean. Right? Discipline, naval architecture. We will learn after, say, next week. Well, naval means a navy, right? You know who is architecture? Right? Architecture usually designer for building or house, right? In land side. So many thousand years of history also. But navy architecture means the architecture for navy. Right? So we call this a naval architecture. Because say 2,000 years ago, when Cleopatra and Caesar, there is a war between Egypt and Roma. At that time, the ship is the most important weapon for that kind of big fighting. There was no airplane, there was no car, there was no gun, right? So that the architecture for navy is important, because ship is important weapon, most important weapon. And marine engineering is for engine of ship, and coastal engineering for coast area. For engineering, offshore is another word against to near shore or onshore. So onshore goes to the deep ocean. We say offshore engineering. So deep ocean engineering, we can say. Right? And fish farming is similar to aquaculture. This is important also, because more protein is coming from ocean, and it is cheaper than land-based protein, cheaper, and also quality is higher. Many people are saying. For Koreans, I can say that most of you eating like salmon. When you go to the buffet restaurant, salmon is one of the good dishes, right? Many people like this salmon. But for Koreans, probably 100% of salmon is coming from Norway, and Norway is farming the salmon at the ocean. They have a big fish farming for salmon. Right. So nowadays, for the Norway, export of fish coming from the aquaculture is an important business. All right, that's it for today. Any other question, any kind of schedule or any other business? No question. Then see you on Thursday. All right, bye-bye.